Welcome back, I should say. Welcome, everyone. Uh, my name is Paolo. Today, together with me, Richard, both process specialists in the customer advocacy organization. And today, we're going to be speaking about steep and shallow. When I said welcome back, I need to make a special mention to those that joined us the first time we tried this, when we had some technical issues. You probably still remember it with a we always have a laugh when we remember what happened
Definitely.
in that moment.
It
But
was it was watching an Englishman and an Italian man fail at IT for about 10 minutes before we gave up and waved the white flag.
absolutely, it was fun. It was probably a piece of history of this live stream series. But
I
today
think I
we're
think
just going to make it right.
yeah. Well, I wouldn't say that. Just let's see if it actually goes right before we say
Yeah,
we're gonna make. We're gonna try our best to do it correctly this time.
let's say in general, I'm going to be showing you what steep and shallow is. Most of you may know it as a Toolpath that's been recently added to Fusion 360. I'll be doing the talking and the showing on the software. Richard will be helping with the chat today. So if you got any questions, any doubts, any request for further explanation or any feedback, also if you want to tell us what sort of aspects of Fusion 360 you'd like to be seeing next, then just let Richard know and he'll take care of you.
Yeah. Again, everyone. I imagine the fact that no one's screaming at us in the chat means that the audio is working well. But please let us know if there are any problems as we go on. The only way we'd have known last time is the fact you told us. It would have been quite embarrassing if we'd gone for half an hour without you being able to see any of the dialogues. So yeah, let us know if there's any problems. We'll do our best to sort them out. Uh, yeah, if you don't like my voice, then sorry, there's not much I can do about that at the moment. But
Yeah, same. Or my
it's
face.
well, yeah, I mean, we can just turn your face off, but they pretty much need to listen to you talk.
Yeah, I know.
Yeah, so if you didn't know what steep and shallow is, Paolo's going to be talking about it. It's a really nice toolpath that, oh, honestly, if you start using it, you'll realize how much you didn't know you needed it, if that
Yeah.
makes sense. I did some generative parts about 2 years ago, and the amount of boundaries I had to make to machine these parts was just unreal. If
Yeah.
only we'd had steep and shallow, my life would have been much
Much
easier,
easier. Yeah.
much
I know.
easier. So
Right, let's get going.
yeah, please use the chat, everyone. Please use the chat.
Yes.
It makes life a lot better for us if there's a lot of engagement. We've already got Ice Cream 62 and EAO having their normal live stream chat. So well done, EAO. You got in first this week. The warm feeling goes to you.
Yes. So, as I said, welcome everyone. Paolo Bastianelli here, Richard Stable with me. We're both process specialists. Richard is based in, let's say, a little bit out of Birmingham. I'm based a little bit out of Rome in Italy. So, but we're member of the same team. We've got a cross-country, cross-continent team with
International.
exactly Portuguese, Italians, English, and so on. But what I'll be talking to you about today, as I said, is deep and shallow. The first thing I wanted to show you is some swerve. Everyone loves some swerve. Everyone loves to see a part being machined. And this part that you can see in this image was machined in the Birmingham Technology Center using steep and shallow, as I'll show you later on. So first of all, what is steep and shallow? Steep and shallow is a single toolpath that can machine all sorts of complex 3D shapes and surfaces regardless of how, as the name suggests, how steep or how shallow they are. But it doesn't just simply work with all sort of geometry. It combines different algorithms to pick the best option for different sections of the model. Okay, so basically it will machine steeper areas of your part with is what is a contour algorithm, the contour strategy in Fusion. And then it will machine the shallower regions with the part with either a scallop or a parallel toolpath. So that will be completely up to the user. The beauty of this is that it can be used as a compounded strategy to machine everything at once, but it can also be used with a couple of tricks that I'll show you later, how to you will basically see how to just machine the shallow areas or just machine the steep areas using steep and shallow. It's obviously used mainly for finishing, but it can also be used for semi-finishing. Obviously, it's not a roughing toolpath. But why did we do it? Okay, let's tell you some facts. Steep and shallow, upon running some tests on some analytics, is the fifth most used toolpath in Paolo. In fact, you may recognize the name steep and shallow. If you have ever heard of PowerMill before, you will know it was one of PowerMill's best toolpaths. Okay, PowerMill is another Autodesk CAM package specialized in more complex forms. Okay, so it was the fifth most used toolpath, but when it comes to finishing strategies, it was the third most used toolpath. But if we look at like-for-like comparison between PowerMill and Fusion, there was no like-for-like comparison toolpath. Okay, so there wasn't like, whilst for example in PowerMill there is an equivalent of contour, or there is an equivalent of parallel or of scallop. In Fusion, we had no equivalent for steep and shallow. So we thought, you know what, let's try and bring it in. Let's try and make everyone's life easier by introducing a toolpath that can do literally everything on your components. Okay? We will see several benefits later, but before looking at the benefits, I think it's worth showing you what it can do on the software itself. Okay, so I'm going to switch to Fusion. Now, to give some background again to the story that we mentioned before, if you cannot see the browser in this moment in time on the left-hand side, just let us know, because that was the technical problem that we happened to incur in last time. Okay, so just please, if you cannot see Fusion like it should look, please let us know. Okay, so what is steep and shallow? 3D toolpath. Okay, it's a 3D toolpath, so you find it here. And let's take a look at how the menu will look. First things first, the interface does not look any different than the interface of any other finishing strategy in Fusion. But the most attentive of you may have noticed that there is an additional tab here. It's the second to last tab. It's called Tool Axis. Okay, now we will look at that later on. Okay, that Tool Axis tab will allow you to create a 5-axis steep and shallow strategy. But for now, we're just going to concentrate on 3 axes. Okay, so you will have picked your tool. You know, let's say you've picked your geometry, your heights. Nothing changed on that. Let's now look at the real, let's say the meatier part, the passes tab. Okay, some settings will be familiar, so the tolerance, for example, but some may be unfamiliar, maybe new concepts, like the threshold angle. The threshold angle is basically where you want to tell the software what you consider steep and what you consider shallow. Okay, so everything will be considered from the horizontal, so from the XY plane in this case. If we say 30 degrees is my threshold angle, anything below 30 degrees will be considered shallow. So anything that's got a slope of 0 to 30 from the horizontal, and anything above 30 will be considered steep. Why is that important? Because the software will calculate the steep and the shallow regions with 2 different algorithms. So you've got to be careful in terms of what you pick there as the threshold angle. 30 degrees is, let's say, an industry standard default. So we've been using it as a default for years. People like it. You can obviously tweak it depending on your model, but to get started, I would recommend using 30 degrees. The overlap distance is another maybe unfamiliar concept. Is where you can basically tell the software to have a little distance, in this case 1.8 millimeters, where the 2 algorithms will overlap. Okay? Basically, what we want to avoid by adding an overlap distance is a sharp mark where the 2 toolpaths meet, basically. Okay? And then if we move down in the form, we can see that we have different sections to regulate what the software will consider steep, what will do on the steep areas, and what it will do on the shallow areas. So for the steep areas, The first thing I can notice is a continuous checkbox. So that obviously, if the model allows, if I tick that checkbox, the toolpath will spiral down the component without linking after a 360 degrees sort of rotation. The direction of cut is the same as always, and the step down, again, there is no concept of a step over, obviously, because we're talking about steep areas. Okay, so you're not moving on the XY plane, you're moving down in Z rather. I cannot hear you, Richard, but I'm assuming they can.
Good point. It was me. I was on mute, so no one could hear my typing.
Okay.
So yes, I was saying that, that we tend to think of step over and step down as sort of the two always go together, and that is true for certain things like roughing. But when it comes to finishing, they are normally associated with different types of toolpaths, aren't they? You've got
Correct.
step over when you're doing the flat surfaces and step down when you're doing the vertical
Steeper, yeah.
surfaces. The way I think of this is if I've got like a 1 degree wall and I step over a millimeter, I'm probably stepping down like 20 millimeters because of the steepness of that wall. So that's why we don't rate things in step over when they come vertical. It's always step down. So we're trying to sort of, on that sort of 30-degree or 45-degree tipping point, change from one to the other, aren't we? All the time to try and get the
Correct.
best parameter to drive the surface finish.
Absolutely right. It would make no sense, to specify a step over on a steep wall. As you said, the concept of stepping over is completely irrelevant. If you move down 1 mil, as you said, you can go down easily 10, 15 mil. So right, and for the same reason, if we look at the shallow passes section, we don't have a concept of a step down, but we only have a concept of a step over for the same reason. You're obviously not stepping up or down in Z, you're only moving on the XY plane. Again, as I mentioned before, we've got the chance to say, okay, for the shallow regions, I want you to think of them, keeping in mind that I want to machine them with a scallop algorithm. So I will not choose scallop for my shallow regions. We will look at parallel later on. For now, let's concentrate on scallop. For scallop, we can tick this box to basically, again, allow for continuous cuts. And on a very flat surface, as I will show you later on, it's really nice to have that option. Continuous cut will mean no witness mark whatsoever, no mark left by the links. Even if they're microliths, they will still leave a mark. And then we've got the direction of cut again, this step over, and these two checkboxes, which I will just name for now, but we will speak about in a second. So smooth offsets and remove cusps at junctions. I don't want to spoil the surprise because they're really good options to have, and you will see why I mean this in a sec. Okay? So I'm going to close this down for a second. I'm going to change my model and concentrate on this one. Okay? So you can see big component, quite freeform, relative lot of steep regions, but also quite a lot of shallow regions. Perfect model for steep and shallow. Okay. On a toolpath like that, like Richard mentioned before about boundaries, I would be creating boundaries for a while. Okay. If I wanted to do that with little pieces of individual toolpath. Okay. Now let's think, for example, of scallop. Okay, I quite like the way scallop works, and in this case, I have a good way of telling the software where to machine. Well, I can use the slope tick box to say, okay, just do the areas between 0 and 30 degrees. So this kind of mimicking what steep and shallow would do. It's a good toolpath, it's excellent toolpath. There's some minor things that I would like to put my eyes on, which are these little sections here. Okay. If I look, there's some very sharp changes in direction. Okay. Now, the way the toolpath works, if we look here again, the way the toolpath works, it will offset the shape from the outside until it collapses basically in. That will inevitably end up in some very sharp changes in direction and in some little regions of leftover material. Okay, again, the way offsets work is not Fusion's fault, is the way geometry, and the way the offset works will inevitably leave some regions where the specified step over is exceeded. Okay, what that means, we will leave some material on the part. It could be not a big deal, but it can be a big deal. Okay. Now again, we do have a way to to think of these sharp corners as detrimental. They're obviously a problem. They're a problem for surface finishing. They're a problem for the tool life. Obviously, such a sharp change in direction for your tool may mean extra engagement. And it can be a problem for the machine itself because it's got to change direction that sharply whilst it accelerates. Okay. Now, the reason why I'm showing scallop is to then show you what we could do with steep and shallow. Now, in this case, I'm machining using steep and shallow, but I'm only machining the shallow regions. Okay. How do I do that? I can either set, again, the same thing, my slope from 0 to 30 degrees, or, and that's a little trick, you can set your threshold angle to 90 degrees. In that case, you would only output shallow regions. Okay? Basically, you're telling the software everything between 0 and 90 is shallow. So the software will say, okay, that's fine, I'll just treat everything as shallow. But it will only output, obviously, the shallow passes. Okay? Now, in this case, obviously, I don't want to do that, otherwise it would be machining these regions as well with the wrong algorithm, but I want to do it with this slope setting that I have. And if I zoom right in on the same section as before, we can see two things. The first, the offsets have been smoothed massively, so there is still a strong change in direction, but at least it's a smooth circle rather than a pointy end. And Fusion has added this beautiful center line in the center to get rid of all those little islands of leftover material. Now, how do I do both those things? With those two checkboxes that I kept secret before. So smooth offsets will make those sharp corners into some radii, and remove cusps at junctions will allow to add this center line that is going to get rid of all that leftover material. Okay? Now, another thing I want to mention, another thing why steep and shallow can really add some benefit to the way you machine your parts is under smoothing. We added this evenly spaced points option where you can decide the maximum spacing that you're allowing between two consecutive points in a toolpath. Now, that will mean, first of all, for those of you that may have some maybe more dated machines with limited memory, you're going to have basically going to have less room if you increase the maximum spacing. At the same time, that may be not the best for your toolpath, but the real great benefit of this is that some people are actually using steep and shallow instead of 2D contour because of this evenly spaced points option. It's really a game changer, and we obviously hope to release this for more toolpaths. But obviously we got this benefit right now, and I think you should start to use it and realize why evenly spaced points will make a massive difference to your surface finish on your components. Okay. Now, I've showed you the two secrets for scallop. We've obviously spiraled down with a continuous pass. Let's look at raster for a second now. Okay. Now, again, in this case, I am machining the whole component. So I'm not just working on the shallow areas anymore. I'm just letting the software go crazy. If you see, I don't have slope ticked, and in passes, I've set my threshold angle, I've set my overlap distance, and I've set parallel as the style for my shallow passes. Okay. Now, obviously, between scallop and parallel, you will see different settings appear. In parallel, we have a checkbox called fixed direction. Why is that important? If you leave it unticked, the software will automatically find the best orientation for your parallel passes depending on the area on the surface. Okay? What does that mean? you get the optimal solution geometrically. You can still choose a fixed direction, and that direction will be calculated from the x-axis of your xy plane. So you can still choose it, absolutely no problem. You get compass direction and you set, I don't know, 15 degrees, for example. But if you leave that unticked, the software will do the maths for you and will pick the best possible solution, not for the whole model, but for every single area of your model. Obviously on the shallow regions only. And then there's another important setting to be underlined, which is wall clearance. Now imagine, and now let me quickly switch to the correct slide. Why is wall clearance important when we're machining with parallel? Imagine every time you get your tool too close to the wall, the tool will not cut the wall, but it may slightly touch it, and you basically get a little nibble at the material at the end of every parallel pass. Obviously, that's not something you want. At the same time, you also don't want it to be too far away from the wall, because you end up with too much material on the wall. And let's say we didn't have an overlap concept, you would end up with leftover material regardless of compounded toolpaths or not compounded toolpaths. But the combination of wall clearance and the overlap distance will really make a difference when it comes to this. Okay? Now, I want to underline a couple more benefits that I mentioned before on the software, but I want to explain again with additional images. First of all, as I said, when you choose scallop, within steep and shallow, you can choose to run the shallow regions on continuous spiral passes. Okay, so on the left, you see an image without continuous ticked, on the right, one with continuous ticked. You can see that there is no linking moves. There is no need for all those little green lines that you see on the left-hand side. So all those, even if you want to, mini retracts, you're still inevitably going to leave a little mark every time. Another benefit I already mentioned is the overlap. The overlap will end up reducing all those marks that you would have where the steep and the shallow regions meet. Okay. We've already mentioned the wall clearance, and the next one I want to mention, which I've already spoken about briefly, was the automatic parallel angle. So if you remember what I said with infusion, if you leave that fixed direction not ticked, the software will automatically optimize the angle of cut per region. Okay, so for each region of your part, for each region of your whole component, it will look at how the surfaces now, how the regions meet, basically, and optimize the angle of cut based on that. That will in turn reduce your cycle time, okay? Because otherwise you may end up with a non-optimized toolpath, but you can still obviously choose to go for a fixed direction that you know, okay? Now, that pretty much concludes the three-axis section of steep and shallow, okay? Now, did we have any burning questions, Richard? I cannot hear you.
Can you hear me now?
Yes, I can.
None that we haven't gone through in the chat, but
Nice.
I think one thing I do just want to say about this is that it's a toolpath that you could have theoretically have done before steep and shallow, but imagine the time it would have taken you to create boundaries and define touch surfaces and then start trimming everything.
Mm-hmm.
And it doesn't matter if you're making a mold tool or if you're carving wood to make a sculpture. This is all stuff that is going to not only save you time, but it's going to reduce wear on the tools. You're not going to be rubbing the flutes on the side of steep walls. You're going to be creating a better quality component overall. So yes, you could have done this before, but it would have driven you crazy to have gone to it in this level of detail and produce this toolpath with just the few clicks that Fusion can do it with. So that's just one thing I do want to stress. I've had a couple of questions about the functionality side, and it's not that you couldn't have done this before, it's the fact that you couldn't have done it with this much ease and automation before.
Oh yeah, no, I reckon this toolpath to set a steep and shallow toolpath to a great level probably takes it can take you 20 minutes, half an hour to tweak it a little bit after a couple trial and errors. But to do this normally, dividing the part yourself, and again trying to reduce marks on the overlaps, trying to avoid toolpath spilling on the sides, trying to do things per boundary would take probably 2 working days. I don't know, but maybe not that much, but still a good amount of time. Can I hear you? We can.
Surely
now.
you can
We
hear me
can
now. I think there's a bit of a delay on when I press unmute. The part on the screen there is actually a mold tool for a carbon fiber part, but again, it just doesn't matter what you're doing. If you want high quality freeform surfaces, be it wood, resin, steel, titanium,
Yeah.
fiberboard, whatever you want to make, if you want good quality 3D surface finishing, this is definitely the one-stop toolpath to give you those without having to spend your life editing the toolpath. And that's why we put it in. We've got some really nice roughing toolpaths, and we felt like this just complements it so well.
Yeah, it really is a game changer. And we haven't spoken about 5-axis yet.
Yeah, go on then. I'll let you crack on with that.
Yeah. So for those of you that remember what I said at the very beginning, we have a surprise tab for you. Okay. Those, as I said before, I call them the most attentive of you, but now you probably have seen it all. The second to last tab has been added to the steep and shallow UI. Okay. Now that is at the moment the only toolpath. Steep and shallow is the only toolpath where you can see this extra tab. Okay. Now, what can we see? We see 3 sections: tool axis, collision avoidance, and tool axis limits. Okay. Tool axis will basically let you pick how you want your toolpath to start. Okay. How do you want your main, as it's called, primary mode? How do you want your tool orientation to begin the toolpath? Okay. If I pick vertical, that's fine. I've got 5 more options. Okay. We'll explain them in a second. Lead and lean, from and to point, and from and to curve. Okay. Now let me quickly switch to my PowerPoint to explain to you what the difference is. Okay. With vertical, you're telling the software, keep my, I'm gonna use this. The green screen doesn't make it visible. Let's try with the pencil. Yeah, there we go. So keep it vertical. Okay. Start with the tool basically aligned with the z-axis for that given setup or toolpath. Lead and lean are new concepts. So if you see on the image, the line in red is the direction of travel. So my tool is going in the direction that is explained there. Now let's say again, my pencil is my tool and is moving towards the screen, towards you. If the tool basically tilts in the direction forwards or backwards, but in the direction of travel, that is the lead angle. Okay, lead or lag. If the tool tilts perpendicularly to the direction of cut, that is the lean angle. Okay, so you can basically tell the software, start the toolpath, always keeping in mind that I want you to stay 5 or 10 degrees tilted, let's say, in the direction of cut. Why would you do that? You would do it not to cut with the center tip of a bottom of the bottom of your ball nose tool, for example, of your bull nose tool, your tip radius tool. You don't want a ball and bull nose. You never want to cut with the bottom, really, unless you're machining something that's flat in one case, or unless you really want to in your tool.
Yeah, again, we go back to a couple of weeks where we did the chamfering one. Remember, if any of you watched that one. If not, go watch it right now. Remember, we spoke
not
about...
right now, but in 20 minutes.
remember we spoke about the fact that there's that sweet spot on a tool. It's the same for these, freeform cutting tools, the bull and ball nose. Try and say those again. You don't want to be on that center tip because effectively it doesn't spin, it's staying stationary.
Exactly.
You want to be on the edge where you've got, a lot of inertia, a lot of strength in the tool, and so on. So again, this is just all about how you influence the tool to try and and get onto that good portion of the cutting tool rather than cutting on the bottom.
Exactly.
But yeah, I'll let Paolo. I'll stop interrupting you now.
No, man, it's absolutely it's best. Otherwise it's a monologue. Like this, it's nicer. It's they hear it from two different people. Who would just trust me? I'm Italian after all. So
I wasn't going to say that. I was very tempted, but I thought no,
I
because
I know you would.
we've got a few people from just outside Milan today. So yeah, I was being very good on my behaviour.
Buon pomeriggio. But yeah, let's go back. So as I said, we will see an example of why you would use these in a sec. Then we have from and to curve. In from and to curve, you're basically telling the tooltip to drive towards or away from a curve that you've sketched in the design tab before. Okay. Where is that good? Like cylindrical component. If you're doing a donut shape, for example, half a donut, you're doing the female of a donut, for example, a cavity, you will be drawing a circle. Or anyway, you can do concave and convexes and convex regions with from and to curve. Similarly, from and to point work in the same way. So the only difference, you sketch a point rather than sketching a curve. The tooltip will drive towards or away from that given point, keeping it as a reference when it basically moves to machine. Okay. Now let's go back to Fusion and let's show you what this does. We'll look at collision avoidance and tool axis later on. Okay, so I'm going to change my model to show you an example of from and to point. So let's say I want to machine this surface here. Okay, that one there. I've already, as you can see, I've sketched a point. Now the distance does not really matter. It's not that important, the distance of the point from between the point and the surface. In this case, I've got my steep and shallow toolpath. Okay, shaft and older modes on. I've picked my geometry, done everything in my passes. If you notice, I've set 90 degrees threshold angle. You remember the trick before? In this case, I've told the software to do it with a 90 degrees threshold angle because I want to machine only this section, but I want to machine it with parallel, okay? By using the benefits of steep and shallow, including, for example, the directions or whatever else you want to pick. So let's look at how this will look when simulating. Let's speed it up a touch. If you notice, the tool runs back and forth, always maintaining that given point as the reference when changing its tool axis. Okay? Again, that to me is a game changer. To do something like that before would have taken substantially longer, I would say. And imagine how many things you can do with just a point as a reference. Again, spherical component, freeform surfaces, pretty much anything that where you can see, you can envisage a point being the driving element for the given toolpath. Okay. I've also got an example for curve. Okay. And I'm going to tell you a couple extra things why you would use this. Now let's look at this toolpath. I can already see a few problems with it. Okay, there's some missing segments. If I go to edit the toolpath, I've got shaft and older mode on. We trimmed, that's why there is some missing segments, right? I reckon that's the reason. Let's take a look at the simulation and let's bring it round about where it stops machining just one side. Let's say
so much hassle about a year ago. I was making a generative seat bracket for Martin Ashton, if anyone out there is a mountain biker, and I had to trim the toolpath so much with boundaries to stop this sort of collisions from happening. This would have just been. I always want to go back and machine it again now, just
for the
to
sake
use
of it.
this.
But if we look exactly at what just what Richard is saying is one step down, we bash into the part. Maybe two step downs, let's say, because we go probably 1 millimeter, I've said here. Okay, so what Fusion does, really intelligently, okay, it trims the toolpath. Fair play. However, I know I've got a way to machine everything still using the same toolpath, which is deep and shallow in this case. I go to tool axis. First of all, again, trimmed, so saved, shaft, and all the modes. I'm still saying if there is anything that collides, just get rid of it. Just please take it away. And if I look at the tool axis tab, I've set to curve as the primary tool axis mode. What does that mean? Let's take a look at it from an angle. Let's simulate. Let's move forward a little bit. If you see, the toolpath will machine my part. Let's make it a bit forward again. Yes. Will machine all the part, so it will not just stop, and will have the tool point towards the curve that I sketched before. Okay, let's look at it from this angle to show you it's a curve. It's just a simple line, nothing too fancy. Being the component nice and symmetrical, it's easier to do it just with a line. That's why I said it's limiting to say when would you use from curve or when would you use from point. It's hard to say you use one for this case and one for another case. There's different options for different cases, but as I said, concave or convex areas, anything that you can see having a line, a more complex curve, a circle, anything as the driving element of where the tool will drive towards or away from. Okay? So, we've seen from point, we've seen to point, we've seen the rest. Let's look at lead and lean now. Okay? Lead and lean is the one where I mentioned, right, let me show you again. Let's go back to it. The direction of travel is key. Okay, where are we going? In which direction are we going? Where do we want to tilt? Do we want to tilt in the direction of cut or perpendicular to the direction of cut? So, if we go to the tool axis tab, in this case, as you see, I've picked lead and lean, and I've only picked a 5-degree lead or lag angle. Okay, in this case, it's a 5 degrees, so it's a positive angle. I've not touched the lean angle, and I'm going to mention these extra parameters which we haven't looked at yet, the smoothing distance and angle. They will both give some room to the software to decide where it could be best to basically smooth the angle transitions without impacting toolpath safety, of course. So all it does is try to improve surface finish. It's not going to cause you any problems. But obviously, again, you've got to find a sweet spot. I would always recommend starting with the defaults and then trying to tweak them to see what happens. So in this case, I've got 5 degrees, okay? What would that mean? We're basically, again, I'm sorry to dwell on this, but going 5 degrees in the direction of cut. So the tool is going to be tilting. Let's take the pencil again. Just 5 degrees in the same direction of cut. In that way, we're going to allow ourselves to not cut with the center of my tool, okay? That would be, it's not going to be a huge problem, but you're not going to get a good surface finish. Very simple, okay? As Richard said, that part geometrically, mathematically does not spin. So let's look at what this does. Slow it down in this case. So you see, if I look from an angle, every time it's got to do one of the parallel passes, because it's doing it parallel, it tilts slightly 5 degrees in the direction of cut. So it basically leads the way in the direction of cut. What will that mean? We're not going to cut with the bottom of the tool. We're going to get a much, much, much better surface finish. Okay? Again, in this case, for lead and lean, you don't want to go, with there's really not a recommended default, and you don't want to go, listen to somebody that tells you use this angle all the time. It's going to be different. It's going to be different based on your application, going to be different based on the material you're cutting, on the tools you're using, on a lot of different aspects. So it's hard for us to tell you, use this number for lead or use this number for lean. It will really depend a lot on what you're doing. But I do recommend taking a look at lead and lean, as it's one of the most powerful options that we've got. But my personal favorite, and I kept it for last, is the collision avoidance section of the tool axis tab. Okay. Now let's look at this part with this again. So the collision avoidance tab, you can tick it. I didn't hear you, Richard. Where you?
This is going to blow everyone's mind. This is when you show them this.
Yeah, I really hope so, because it's really, really powerful.
Or maybe we just realize how sad we actually are that we
It
find
could
this
be.
stuff so
Could
interesting.
be. It could also be possible. But I'm sure if they're joining us in the,
They're just as sad, are you trying to say?
No. They're interested. I'm saying we're not sad, and they're interested in what we say. But yeah, so really powerful tool. If you set your, you can set your tool axis to anything. You can set it to vertical, from point to point, whatever. As I said, we've got this checkbox, collision avoidance. Okay, let's go back to vertical, where we have 5 options. So from to point and from and to curve are, let's say, now names that you should be starting to get used to. And then there's automatic. What the hell does that mean? Give me a second, and I'll show you. We have basically developed an algorithm. This was developed initially for Power Mill. This was brought over together with Steep and Shallow. So this algorithm will look at your component, at your part, will automatically detect any potential collision and avoid it in a completely automated manner. Okay? So you've got 5-axis toolpath, you've got a 5-axis machine, obviously. Keep this in mind, you've got to have a 5-axis machine for this. All you need to tell the software is start vertically. So I want my tool axis to start vertically, so aligned with the z-axis, and then just do your magic. And the software will do its magic for you. It's not just going to avoid a surface because there's a collision. It's going to maintain the angle as much as possible to minimize any jerky movements on the machine that will then mean not great surface finish. Okay? So from and to curve and from and to point will also work quite well. Same concept as before. The difference between before and now is before, from and to curve and point were options with which the software would start the toolpath. Okay? The software would already point towards the curve or towards the point when it starts. In this case, from and to curve and from and to point are options that the software will just rush to in case it needs to. You can set your tool axis mode to be vertical and then say, in case you need to, just point towards the curve or points towards the point. Or you can just say, just do it for me and select automatic. Okay? Automatic is really the one-stop shop for 5-axis deep and shallow. Now, just to show you, this is a big component. Okay? We're talking, let's look at the setup. So 800 by 650 by 320. Okay, big component. Sorry for the American folks, but I'm sure you can see the size of it. That is a 12 mil ball nose, to give you an idea. Okay, big component, and you want to say, are you actually doing it with one toolpath only and such a short tool? Yes, I am. So this is a finishing strategy, no stock to leave. All I had to set was what I showed you before, the threshold angle. Uh, I've got no machining boundary, no problems there. I want to say I want to do my steep passes in a continuous way, 2 mil step down, shallow passes, 2 mil step over. On smooth offsets, I want to remove Casper junctions. I'm not doing anything else. And then I'm going here and I'm saying to the tool, stay vertical. So start vertical and stay vertical when you can. But in case you need to, just work your magic out. Okay? And we're going to quickly simulate this to show you that I'm not lying when I say this is not an image. We're actually going to speed things up a little bit. You see, it's ordered by top because I told it to start at the top. And you see, let's slow it down now, it's changed orientation and is staying at the orientation because to stay there as much as it possibly can to maintain an excellent surface finish along that wall. It would be stupid to go back to 3-axis just for a little section of that pass to then go back to 5-axis and then go back and forth. Okay, you obviously want to minimize axis rotation as much as possible. Let's move on. Let's go somewhere around there. See another section. Again, that way we would have risked collision with that wall if we stayed vertical. So the tool has decided, you know what, I'm going to tilt, I'm going to stay at that angle.
There is just how short that tool is.
Exactly.
I mean, I know how many times I've gone like, "Ooh, I know I shouldn't stick the tool out this far, but I need to make the part, and I haven't got the time to start making 50 tool paths on it." Look how short that tool is.
Exactly.
So your finish is going to be brilliant because the tool is so short, and
Low
the tool path's
vibration.
going to make, that is, Paolo, you've
And,
made my day.
and you've got to look at another thing I want to underline is how how many I can generally count probably on two hands the amount of green and yellow lines that I can see.
Yeah, good point.
So there is literally no time wasted whatsoever.
Yeah, I used
As
to.
little air cutting as possible. There's no problems on that.
Yeah, I used to work in a forge, and if the managing director used to walk in the die shop, and if the machine was ever air cutting, he used to get his stopwatch out and start timing the amount of air cutting just to make sure it was done.
Well,
So yeah,
to be fair, I think that's a good way of educating somebody in terms of what air cutting is.
yeah,
To make it to the next level, to bring it to the next level, you should have converted that into how much money the machine would be making if it was cutting metal
yeah.
at that
Well, no,
moment.
what he used to do is he used to go to the operator. That's just taken 10 minutes of air cutting. Do you want a 10-minute extra lunch break? That's how he. I mean, we've got people in the chat. We've got a cash going. His mind is now blown. So
Yeah.
yeah, it's some seriously impressive
Said
stuff.
I've kept it simulating because it's just honestly beautiful to
It's
look
too
at.
good to stop.
It's beautiful to look at. Like look at how it does everything itself. I literally had to do nothing. I had to say just automatic.
Do your magic.
Do the thing that you know to do best. Do what you know.
Yeah.
Right.
So we need to start a hashtag made with steep and shallow.
Yeah, absolutely. My steep and shallow can generally change the way you do complex
The world.
freeform. Can do the way change the way users can create parts quicker, create better parts quicker, really, with a fraction of the time. Not just quicker. So, do we have any questions, any comments, any feedback, any
Other than people just downright astounded by
by steep and
those
shallow?
those lovely blue lines across the part. It's
Mm-mm-mm. You see,
yeah,
the tool is hiding now behind. So be shy. Let's
yeah,
bring
it's a
it
bit
to
shy
this
now.
side.
It's done its magic. It's gotta hide now. But no, I think yeah, just generally. Again, I'm not going to say it again, but yes, we're doing large scale mold tools here. But I've seen people there's a guy, I can't remember his name now. he basically he machines out famous mountains from across the world
Oh,
out of
cool.
wood, and then you fill it up with resin. And like if someone's climbed a mountain, like they go and climb Snowdon, you can get like buy them as a gift, and you can
That's
get the
cool.
things etched into it. You like you climb Snowdon on this date, and I just think like this sort of toolpath, even for machining in wood,
Oh, perfect.
is just gonna yeah,
Absolutely perfect.
yeah. So the steep and shallow toolpath, yeah, is
Absolutely something I would recommend trying out, guys.
yeah,
I
definitely.
if you haven't yet, just go try it out. Trust me.
Yeah.
And yeah, so yes, if nobody's got any urgent burning question, I think I'll leave it there so
No, that
that
is
I wasn't
brilliant.
overly long. I don't
Thank
want.
you for doing that, Paolo. There's no way I could have done that in that much detail.
That's
Yeah,
absolutely. I'm happy to talk about this stuff whenever possible.
very good job. Someone's asked about what's the minimum graphic specs for simulating like that.
I think
I don't know.
you can find the recommended specs on the on.
Yeah,
I think it's on Fusion.com. Fusion, well, but definitely on the Fusion website. I can't remember
I'll have a look. Yeah, there's the
what is
recommended
the.
specs. I have not got a clue about the minimum. I'm not going to lie, we've got pretty decent laptops, so it seems to work quite well. But
Yeah,
I do a lot of work in my garage on a Microsoft Surface, one of the older ones, and it handles it fine. So that definitely won't have a dedicated graphics card. That will just be the inbuilt one.
yeah.
So
No,
yeah,
mine and yours definitely have a dedicated graphics card, but as
yeah,
you said, it's not necessarily required. That's like the bare minimum. It's obviously recommended, but
yeah.
it's not.
Fusion minimum requirements.
Yeah,
It's just basically saying integrated or
perfect,
separate graphics with DirectX 10 or higher. That's all it's specifying. So
perfect.
you don't need anything too wild, really. Of course, the better you go, the better it's going to be.
Yeah, but that applies to everything, doesn't it?
Someone's asked about, is it possible to simulate a machine in Fusion 360?
Give us some time.
Ask that question in a number of months,
Yeah.
and you'll have a very pleasant answer. Yeah,
Let's say we cannot say yes, but I'm also not going to say no.
yeah, yeah. So yeah, we can't say anything more than that. Yeah,
Now
Diego's thanking
you can see
us.
from the smile you're excited. We're all
Yeah,
excited.
we are excited. Akash is going to try it today. Well done.
I'm very
Post back on
happy.
the forum. The forum's always the easiest way to get in touch with us,
Yeah.
everyone. So if you ever want to get in touch with us personally, go on the forum. And yeah, and we'll try our best to answer there. But yeah, I'll let you wrap this one up, Paolo, as you've done all the hard work.
Yeah, no, that's all right. Well, really, I just wanna thank everyone for the time, for the attention, and hopefully we've done a good job at explaining why Steep and Shallow is a game changer for finishing toolpaths in Fusion 360. All right, guys. So again, if any of you wants to watch this again, or if you've missed the first half or something, is going to be available on YouTube on the Fusion 360 channel. Um, Again, spread it with friends, share it. Just give it out in case they need to know with colleagues and everyone. And yeah, let us know if you've got any feedback and any suggestions for future topics to be covered. Okay. Thanks, everyone.